interaction of control loops. Interaction means already I told you that if you adjust M1, we give a step change in M1, you can see that there is a change in Y1, there is a change in Y1 as well as Y2 means M1 has interaction with Y2. Suppose M1 is used as a manipulated variable to control Y1 means M1 has interaction with Y2. Similarly, let us assume that M2 is used to control Y2. If you give a change in M2 means there will be a change in Y1 means M2 and Y1 are interacting. M1 and Y1 are interacting. If you find, let us find the transfer function, all these interacting loops. The change in Y1 with respect to change in M1 is called H11. The first one is called output, H11. In that H11, first one is Y1. Second one is input. The first one is output. Second one is input. H11 means it is the transfer function for Y1, for change in Y1, for change in M1. That is H11. Suppose what is H21? H21 means change in Y2, because first one is already I told you that it is output. Change in M1. For change in M1, what is the change in Y2? If you find, you will get the transfer function H21. Similarly, for H22 means for change in Y2, for change in M2, that is called H22. H12 is what? Change in, that is H12 is change in Y1 for change in M2, that is called H12. So there are 4 transfer functions. How many inputs are there? Only 2 inputs are there. For that, we are getting 4 transfer functions. This is input-output transfer function, input-output transfer function. This is also input-output because the input is M2, output is Y2. This is input-output transfer function. These 2 are interaction transfer function or disturbance transfer function. Interaction transfer function or disturbance transfer function. That way we can consider H21, H12. So this is the process we have to imagine. It has 4 transfer functions. If 2 inputs are there, how many possible combinations? How to select to control M1, whether we have to use M1 or M2. Similarly, to control Y2, whether we have to use M1 or M2. How to select that? How many combinations will be there? 2 factorial. 2 factorial equal to what? 2. Only 2 combinations are there. One is M1 can be used to control Y1 or Y2. That's all. Similarly, M2 can be used to control either Y1 or Y2. That way, there are 2 possible combinations. Only 2 possible combinations that we have seen here. Here, Y1 can be used, M1 can be used to control Y1. M2 can be used to control Y2. That is first combination. Second combination is M1 can be used to manipulate Y2 and M2 can be used to manipulate Y1. M2 can be used to manipulate Y1. There are 2 possible combinations. From that, which gives better qualitative performance, based on that we can select either this or that. But suppose there are 4 input means 24 we have seen. 5 means 5 factorial. 5 factorial. 120. 120 possible combinations. If it is 5 factorial equal to 120 combinations. So out of 120 possible combinations, we have to select only 1. Here, suppose we are using M1 to control Y1. Similarly, M2 is manipulated variable. M2 is used to Y2 means, how we'll close that? The feedback path is from Y1 and the feedback is given to GC1, controller 1. This is controller 2. Controller 2 is to manipulate M2. Controller 1 is to manipulate M1. Now, we can see the interaction in direct and indirect interactions that we have seen. For example, let us assume that this loop is open. Let us consider that. So there is no closed loop in the second loop is kept open loop. Let us assume. In that case, suppose I am controlling y1. I'm controlling y1. Controlling y1 means what? M1 is manipulated. Because of manipulation in M1, y2 will be affected. Y2 will be affected. You understand this? This is called direct interaction. M1 has direct interaction on y2. The M1 will have indirect effect on y1. That we will see now. Suppose both loops are closed. Both loops are closed. In that case, to keep y1 equal to y set point, M1 is manipulated. M1 is manipulated. That has direct effect on y1. And at the same time, it deviates y2. It deviates, M1 deviates y2. Because of the deviation, it is in closed loop, That's why this GC2 will take necessary action to control y2. That's why M2 will be varied. There is no change in y2, but there is a change in y1 only. There is a change in y1 only. Initially, there is a change in y1 only. Because of that, M1 is changed. Because of change in M1, y2 is now changed. While controlling y1, y2 is changed. Because of that, M2 is manipulated. Because of that manipulation, M2, y1 is deviated. So, this is called indirect effect of interaction. Now we can write the equation for y1. y1 equal to h11 m1 plus if any change in m2 also, that will affect y1. That is added here. That's why we can write h12 of m2. Similarly, y2 equal to what? y2 equal to h21. H21. If any change in m1, that will affect y2 plus h22 m2. This is the open loop relation between y1 and m1 m2. Similarly, y2 and m1 m2. This is m1. Sorry, h21 m1 plus h22 m2. So this is what we wrote here. So h11 m1 plus h12 m2. y2 is equal to h21 m1 h22 m2. If you consider both loops, this is open loop. If you close like this, both loops are closed means what is M1? M1 equal to the difference between this, that is GC1 multiplied by y1 set point minus y1. Similarly, M2 equal to GC2, the controller multiplied by y2 set point minus y2. That's what we got, that second equation. If no interaction is there, this you will get. If no interaction, this you will get only if no interaction. If interaction is there, if you substitute these two equations in the first two equations, you will get this 7 and 8 equation. And if you find the transfer function, if you find the expression for y1 equal to p11 y1 set point plus p12 y2 set point, because change in set point 2 also will affect y1. Any change in y2 also will affect y1. That's why it is function of both set points. Both the set points where p11, p12, p21, p22 are the function of h11, h12, h21 and h22. These and all mentioned here. Where q of s is also function of h11, h21, h12, h22. So that is written here. So from this, if you substitute h12 equal to h21 equal to 0, then you will get the fourth and fifth and sixth equation. So it is, if no interaction is there, then only we will get the conventional transfer function for closed loop. Otherwise, you will get the interaction equation like 9 and 10.